Hello mga numbers. Welcome to my channel. My name is Jonathan, who is passionate and in love with mathematics. And in this tutorial video, I'm going to tackle some of the formulas of double angle identities. But before we begin, if you're new in this channel, please don't forget to like, subscribe, and the notification bell for more updates. And by the end of this video, I'll make sure you have a clear understanding on how to solve using the double angle formula. So grab your calculator and let's get started. Double angle formula are used to express the trigonometric ratios of double angles in terms of trigonometric ratios of single angle. The double angle formula are special cases of the sum formulas of trigonometry or where it derived from. Now, let us recall the sum formulas of trigonometry of sine, cosine, and tangent. For the sine, we all know that the sum formula of sine is sine alpha plus beta is equal to sine alpha times cosine beta plus cosine alpha times sine beta. In cosine, we have cosine alpha plus beta is equal to cosine alpha times cosine beta minus sine alpha times sine beta. And for the tangent, we have tangent alpha plus beta is equal to tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Now, we will verify the double angle formula of sine, cosine, and tangent. Now let's start for sine. We are already given the sum formula of sine. Now, if we let alpha is equal to beta and beta is equal to theta, then we have sine theta plus theta is equal to sine theta times cosine theta plus cosine theta sine theta, and that makes sine 2 theta is equal to 2 sine theta cosine theta, and that is the double angle formula for sine. And let's proceed for cosine. For cosine, same process for sine. We let alpha is equal to beta and beta is equal to theta. Then we have cosine theta plus theta is equal to cosine theta times cosine theta minus sine theta times sine theta. Then we get cosine 2 theta is equal to cosine squared theta minus sine squared theta. And for the tangent is also the same process. We let alpha is equal to beta and beta is equal to theta. And we will substitute theta to both alpha and beta. Now we have tangent theta plus theta is equal to tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. And that makes 2 tangent theta over 1 minus tangent squared theta. So this goes our double angle formula for tangent. Make sure that you write down those 3 formula because we're going to use them soon. Here is an example on how to solve using double angle formula. If the theta is greater than 0 but less than 180 such that sine theta is equal to 5 over 13, find the double angle of sine, cosine, and tangent. The first thing we need to do is to draw a right triangle. And notice that the angle theta is in quadrant 2. So, that's we're going to draw the right triangle. So here's the angle theta in the standard position. Sine is the opposite divided by hypotenuse. We use the Pythagorean theorem to get the value of the missing side, which is the adjacent. Now let's say x is equal to square root of 13 squared minus 5 squared. 13 squared is equal to 169 minus 5 squared, which is 25. And 169 minus 25 is equal to 144, which is square root of 144 is 12. And remember, according to the ASTC rule, that in quadrant 2, only the sign and its reciprocal are positive. So our adjacent will be negative 12. Now, we can find cosine. Sine theta, according to SOHCAHTOA, it's equal to the adjacent side divided by the hypotenuse. So, that's negative 12 over 13. Now we need to find the tangent theta. Tangent is equal to opposite over adjacent. So in this case, it's negative 5 over 12. Since that we have sine, cosine, and tangent, we can now solve everything. Now let's find the value of sine 2 theta. Now we have the value of sine theta, which is the 5 over 13, and we have the value of cosine theta, which is negative 12 over 13. So all we got to do is just plug this onto the equation. So 2 is the same as 2 over 1. So we need to multiply 2 times 5 times negative 12, and it's equal to negative 120, and 13 times 13 is 169. So negative 120 over 169. This is now the value of sine 2 theta. Next, we need to find the value of cosine 2 theta. Cosine 2 theta is equal to cosine squared theta minus sine squared theta, which is negative 12 over 13 squared minus 5 over 13 squared, and it's equal to 144 over 169 minus 25 over 169, equal to 119 over 169, and that is now the value of cosine 2 theta. And lastly, let's find the value of tangent 2 theta. Tangent 2 theta is equal to 2 tan theta over 1 minus tangent squared theta, and it's equal to 2 times negative 5 over 12 over 1 minus negative 5 over 12 squared. You can pause this video to solve this equation. And now the value of tangent 2 theta is equal to negative 120 over 119. Now we solve all the value of double angle by using double angle formula. Now let's talk about the real-world connection of trigonometric concept. Double angle identities are trigonometric identities that involve trigonometric function of double angle. These identities find application in various real-world scenarios, especially in mathematics, physics, engineering, and other fields. Some common application of double angle identities includes solving trigonometric equations, trigonometric integrals, trigonometric identities, geometry, waveform analysis, mechanical engineering. Overall, double angle identities are versatile tools that find application in various fields where trigonometry is used to model or analyze relationships involving angles and periodic functions. And that's it for today's video. If you learned something, please don't forget to like and subscribe to my YouTube channel. Bye mga ka-numbers!